Innovation is the cornerstone of success in America. In order to compete in the global marketplace, businesses and individuals are continuously striving to stay ahead of the game. I'm Terry Bradshaw. From emerging technologies and financial strategies to the latest healthcare developments, you would be surprised by the many factors coming into play. Welcome to Today in America. Technology may have been born from the synergy between science and industry, but its ultimate value lies in the power it exerts to better people's lives. Let's learn how the latest technologies are advancing the human cause.
Tens of thousands of oil and gas wells are drilled every year in the U.S. That's more than anywhere else in the world. A critical part of the process is cementing. It's one of the last steps in the construction of a well, and its effectiveness is paramount to the integrity of the well.
Cementing is the process of filling that small gap between casing and the formation in a well. When a well is drilled, casing is inserted down into the hole, cement slurry is pumped down the pipe and back up between the casing and the formation. When the cement is set, then that provides a seal for your zonal isolation of all your different zones and provides structural support for the well.
Experts say oil and gas well drilling and production can be a safe, environmentally neutral process with good corporate citizenship and proper engineering.
A poor or failed cement job can compromise the seal between the casing and the borehole. The effect of this depends on the severity of the loss. High pressure gas and fluids can and will seek the path of least resistance until they approach an area sufficient to contain them.
According to American Petroleum Institute, or API, specifications and recommended practices, selected cements, additives, and mixing fluid should undergo laboratory testing to make sure the cement slurry meets the requirements of the well design. Tulsa, Oklahoma headquarters Cement Test Equipment makes all sorts of instruments required to test the performance of well cements according to API as well as ISO standards. The company is a member of the API committee that has developed the standardized testing procedures.
Laboratory simulation of the well conditions allows the engineer to use the chemicals and the cements that will be on the well site to develop a cement slurry. And this gives him the best opportunity to design a slurry that will be successful and increases the safety of the operation.
The gap between the pipe and the earth is anywhere from less than a half inch to as much as 2 inches. CTE's equipment tests the slurry for a number of factors.
Our instruments can test at simulated well conditions as high as 600 degrees Fahrenheit and 40,000 psi pressure.
Company officials say the most important test evaluates the thickening time. It determines how long the slurry will remain pumpable.
One of our newest instruments, the 15-400 gel strength tester, is able to measure thickening time as well as gel strength. It's considerably less expensive than that of our competitors and much easier to use.
CTE's instruments are installed in laboratories throughout the world. Each test instrument operates as a standalone piece of equipment and features a display that shows test results. Computer and automation technologies are integrated into the instrument design, which helps to decrease user error and increase precise, usable data streams. The time to develop new slurries is also greatly reduced with easier access to historical data from wells with similar conditions.
Cement test equipment designs and supplies the instruments necessary for us to define the characteristics of our cement systems. They're constantly in tune with the changing needs of the industry and readily adapt to those needs with state-of-the-art answers.
As drilling technology advances and enables greater access to hard-to-reach reserves, CTE expects to continue leading the market with innovative well cement testing technology.